2019 for your response number 2. So this one will be calculator friendly. It's going to be a position, velocity, acceleration type of problem. The velocity of particle P moving along the x-axis is given by a differentiable function that's going to be important for us, where Vp of t is measured in meters per hour and t is measured in hours. We have selected values of Vp of t. They're going to be shown in the table over here. Particle P is at the origin at time t equals 0. All right. So part A, justify why there must be at least one time t between 0.3 and 2.8 at which the derivative of Vp of t, or the acceleration, particle P, equals 0 meters per hour per hour. Okay, so it's asking, is there a value that must exist that's going to equal 0 for our derivative, which should be a clue for MVT. Okay, so when I first saw that, I went back and reread the initial kind of problem up here, and it does say that V of P is going to be differentiable, which also means it's going to be continuous, and MVT holds true. Okay, so that's where we want to begin. I want to say V of P is a differentiable, therefore continuous. Okay, on the interval, well, maybe we want to say on the interval 0.3 to 2.8. Therefore, MVT holds true. Okay, so I'm really looking, is my derivative ever going to be equal to 0? Which is an easy one to figure out because my times, or I guess my values for V of P need to be the same. Okay, so remember, if it's from 0.3 to 2.8, I could be looking from 0.3 to 1.7. I could be looking at 1.7 to 2.8, or 0.3 to 2.8. Okay, so this one stands out in my mind that these are going to be the same. So those are going to be the two values I'm going to want to use to get my derivative to equal 0. So I'm going to show Vp of 2.8 minus Vp of 0.3 divided by 2.8 minus 0.3, which is really going to be 55 minus 55 divided by some number that I'm not even going to reduce just because I know that's going to equal 0. Okay, so remember, like if you really struggle with this MVT stuff, at least do the AROC part of it where it works. Okay? I haven't seen a problem where they ever ask this of you and the answer is no, it's not true. Okay, which some of you have answered on your homework. Okay, it's probably going to be true. You just got to figure out kind of the correct combination. Here, since it is 0, it is a little bit more obvious to see. So 55 and 55. Okay, this is not good enough to get that extra point yet. You still need to come up with your conclusion. So I'd say, so there must exist and I think normally it's C, but here they're still using T.
At least one time T.
There must exist a T kind of between 0.3 and 2.8 such that Vp prime of T is going to equal 0. Okay, so this is one, maybe you guys want to write kind of the setup on your little cheat sheet that you're going to be using for your exam, because it's really, the wording is going to be the exact same, you just plug in different letters and different values here. Okay, that might be a good one that you want to have for your exam. Sweet, so B, use a trapezoidal sum, which we haven't done for a while, with 3 subintervals, 0 to 0.3, 0.3 to 1.7, and 1.7 to 2.8 to approximate the value of 0 to 2.8, the integral of Vp of t. Wow, that's a lot of words. Mm-hmm. All right, so really for part B, what we're going to do is we're saying the integral from 0 to 2.8. Just keep in mind we're not including this 4 and 48 here. Okay, we're only using these 3 parts. Or I guess 1, 2, 3, 4 parts here. Okay, so this is just a notation you guys should be using. Okay, this is going to be an approximation. We could figure out the exact value if we had a formula. We don't have a formula though. Okay, so that's why we use a trapezoid to help approximate. So you guys remember the formula of a trapezoid is 1/2 base 1 plus base 2 times our height, but our trapezoids are kind of on its side. So the height of each trapezoid is really going to be kind of the differences between our times. Okay, our base 1 and base 2 of our trapezoids are going to be our output values. So what I'm going to write here is going to be 1/2. Okay, I'm going to do my height next. So my height of this first one is going to be 0.3 times base 1 plus base 2, which is going to be 0 plus 55. Okay, my next one is going to be 1/2. My base, or I guess the height of the trapezoid is going to be 0.3 to 1.7, which is going to be 1.4. Base 1 and base 2 is going to be 55 and negative 29. Okay, looks like I ran out a little bit of space here, plus 1/2. My next one, the height of the trapezoid is going to be 1.7 to 2.8, which is going to be 1.1.
Oops, I put 1.7, 1.1.
Okay, and our base 1 and our base 2 is going to be negative 29 and 55 again.
And you guys, since this was recent, I remember the kids being like, oh my gosh, why was it negative? And they were all freaked out. Like, it doesn't matter. It's fine. And I mean, you can have negative velocity, it just moves meaning you're moving in a negative direction. So, I mean, this is accumulating from 0 to 2.8. And it is calculator active. I just did 0.5 instead of the 1/2 since we had decimals the whole rest of the way. You don't really have to finish it.
Don't finish it. Stop there.
You could stop there.
We're going to find out later in part D. You're going to need to finish it to kind of answer part D. But on part B, I would just stop there.
It does end up being 40.75 if you finish it.
Which we will need later, but at this point we don't know that yet. Okay, so there's no reason for you to type that into your calculator. The only thing that's going to happen is you're going to lose points. Okay, you're only going to get 1 point, so if you have that, you get your point. If you keep continuing on and get a wrong answer because you typed in one thing wrong, okay, now you get 0 points for all that work. Part C is kind of interesting. A second particle Q also moves along the x-axis. So that's velocity from 0 to 4 is given by v of q equals that mess meters per hour.
That is a mess.
Yeah. Find the time interval during which the velocity of particle q is at least 60 meters per hour. Okay, so we need to figure out the time interval when the graph of vq now is going to be above 60. Okay, so what you might want to do is type that into your calculator under y1, and under y2 type in 60 and see what that graph looks like.
So all our t's are x's, so it's 45 times the square root of x. Make sure you arrow to the right before you hit your cosine button in radian mode. Then you got to be really careful because it's 0.063 t squared, so x squared. There's just a lot of opportunities to make a mistake actually typing that rule for v sub q of t, the velocity for particle q. And then at least y2 is easy to type in. It's just the constant 60.
Okay, so what I would go ahead and do is graph that. Really, what we're going to try to graph is figure out when v of q is going to equal 60.
And 0 to 4 was our time going by once. Mr. Herney did a little zoom fit. If you don't zoom fit and you think it through, well, if I want to know at least where they equal 60, but I also want to know where I'm above at least 60, right, would be more than. So maybe you went like 0 to 70 by tens, but this works out fine. We hit graph. So we have our horizontal line at 60, and then this kind of just curve that eventually hits a maximum and starts to come down. And aren't we going to want to find where those two graphs intersect? So I want to be on my first curve. It automatically jumps me to my horizontal line for my second curve at 60. And that time, yes, for my calculator to guess, is 1.866. Or if you write it all down, 1815. Okay, and then that second time, second calc or second trace, find where they intersect, which is the time further to the right. So we move along the y1 curve first, get closer to where they intersect, hit enter. First curve automatically jumps you to your horizontal line. Second curve, yes, Mr. Calculator, guess that. They only intersect once over there, which is 3.5191744.
Okay, so we just need to answer that part of the question first. So I said our velocity of our particle Q is going to equal 60 at both those times. The question is asking when is it going to be at least, so we want to know when is it that or more. Okay, so it's actually going to be the time in between these.
Doesn't that make sense, right? Like that's where the curve is above the horizontal line. So doesn't that like make sense?
This marker's garbage.
Here, give it to me. It's garbage.
Okay, so I'm just going to answer. I can even open this marker. VQ of t is going to be greater than or equal to 60 at t equals, we're going to go from 1.866 to 3.519. We're going to include both of those because it says at least, so we want to include when it is 60. Then the units on that is going to be, I forgot, looks like hours. Okay. But we're not done with part C yet. So the second part of it is find the distance traveled by particle Q during the interval when the velocity is at least 60 meters per hour. Okay, so remember that if we want distance traveled, we would normally need the absolute value sign in there. Okay? Otherwise, if we just have it without the absolute value sign, that is normally displacement, but our velocity is always positive during that time period, so we don't really need to put the absolute value signs. So really all you need to do here is go from 1.866 to 3.519, but remember, type in all of your values or all of your digits here. Okay, and we're just going to integrate VQ of t dt. It doesn't hurt to put the absolute values, but because we know it's always positive, you don't necessarily need it.
And remember, we stored that rule for the velocity for particle Q in y1. So I typed all the digits so we didn't introduce any rounding error because we have all those digits for both the lower boundary and the upper boundary. Normally we just kind of have like all those digits on only one. And you should get 106.109.
Okay, remember velocity was meters per hour. So if we integrate meters per hour with respect to time, we're just going to be left with meters, which is a distance traveled. And that brings us to part D. At time t equals 0, particle Q is at position x equals negative 90. So let's kind of write that information down. We know that at t equals 0, particle Q is at position. So we're not talking our velocity equation. I'm talking position. So I'm going to put x. We're talking particle Q. So xq of 0 is going to equal negative 90. The units on that would be meters, even though they don't say it. Using the result from part B, okay, find in the function VQ from part C, approximate the distance between particles P and Q at t equals 2.8. Okay, so this is when I went back and I was like, all right, I'm actually going to have to figure out what this number is. Okay, it ends up being 40.75. Maybe you don't want to write that up here just in case that number is wrong that you calculated, so you can still get this point. So I know what is it going to be? XP of 2.8 should be approximately 40.75. Alright, so we need to figure out what is the position of particle Q at 2.8. Okay, we have our velocity equation. Okay, we don't really need to type it all out or anything. But if we want to know the position of particle Q, what I can do is find the position. Oops, I gotta put my little q there so I can keep telling the difference between them. X of Q, so the position of particle Q at 2.8. Okay, understand if I integrate my velocity of particle Q from 0 to 2.8, that should be my position at 2.8 minus my position at 0. And then you could just add that over, and you get something like that.
That was slick, Ernie.
Mm-hmm.
So remember the position was negative 90 for particle Q. And because we stored our velocity for particle Q in y1, so it's negative 90 plus math 9 from 0 to 2.8 of the rule in y1. And you should get 45.938.
Yes. All right. We still haven't answered the question yet, though. It's asking what is approximately the distance between particle Q and particle P at 2.8 hours. Okay, so what you're going to want to do then is take 45.938 and all of your other decimals minus 40.75.
So I want to do that answer minus that 40.75 that we got from the estimate with the trapezoid. And you guys, part of why that estimate is like right is because I don't know if you remember, but way back in the stem of the problem, it says that particle P was at the origin at time 0. So if it's at the origin, its position is 0 at time 0, and that's why we just get the trapezoid stuff. And then you should get 5.188.
Okay, so you just want to answer in words. The particles Q and P will be about 5.188 meters apart at T equals 2.8 hours. Okay, I kind of ran out of room there, but just write those words out. Just explain what you just found, and you should be good. As far as points go, part A, so MVT, that's like always worth 2 points. Okay, I already told you your AROC part will get you your 1 point. Okay, your other point, you have to have your hypothesis and your conclusion. Okay, so that's what I'm telling you. If you guys are struggling with that, which I know many of you are, maybe write one of these down for your cheat sheet. Okay, because I'm pretty sure MVT is going to be showing up on your exam this year. Okay, it's really been showing up a lot lately. Part B is only going to be worth 1 point. Okay, you have to have all of that correct to get your point. Okay, let's say you had all that correct and all of a sudden you said it was type something in wrong and you got like 30.75. Okay, now you get nothing. Okay, so just write all of that out and you're good. Part C, let's see, is going to be worth 3 points. You get 1 point for finding this interval here. Okay, remember it was asking you a couple different things. You're going to get 1 point for having a definite integral here. And then you're going to get 1 point for your answer. Okay, I don't think you need units or anything on that. I just always like to write them. Typically, you're going to get points for units if they specifically ask for you to give the units. And then part D is going to be worth 3 points. You get 1 point for integrating our velocity from 0 to 2.8. Okay, you're going to get 1 point for finding your position of particle Q at 2.8. So really, all you have to do is add that negative 90 onto it, and you're going to get another point. And then the last point is going to be for answering your question that they are separated by 5.188 meters.
At time.
At time 2
2.8
equals 2.8 hours.
Cool.
All right.